Here we go. Starting out the 45, 45, 90 right triangles. 45, 40, and what we mean by 45, 45, 90 is the three angles. We know the three angles in a triangle always add up to 180. Well, what if we have a right triangle? Misplaced. No. What if we have a triangle that contains three angles that are 45, 45, 90? (45, 45, 90). I put this in my notes. First off, what kind of triangle is that? It's a right triangle, and it's also an isosceles. That makes sense? Since you have two congruent angles, you also have two congruent sides. So let me show you a couple of these. Let's see, if this is 3, what's this going to be? 3. It's an isosceles triangle. The two angles are equal, the two base angles are equal, the two sides will also be equal. It's also a right triangle, so I'm going to perform a Pythagorean theorem here. And watch what happens. 3 squared plus 3 squared equals c squared. I'm looking for this missing side. 9 plus 9 is c squared. 18 is c squared, so c is the square root of 18. If you simplify that, that simplifies into the square root of 9 times the square root of 2, which is 3 root 2. 3 times the square root of 2. Let's do it with a different one. Let's do it with, let me write that down first though. So my leg was 3, my other leg was 3, and my hypotenuse was 3 root 2. Let's do it with 4 now. What if my two side lengths were 4? Or just one of my side lengths is 4? If one side length is 4, that means the other side length has to be 4. It's an isosceles triangle. A squared plus b squared is equal to c squared. So now 16 plus 16 is c squared. That means 32 is c squared, which means c is the square root of 32. Does anybody know what I'm going to split the square root of 32 into? Square root of 16 times square root of 2, right? Square root of 16 would be 4 times the square root of 2. So if my legs were 4, I would have 4, 4, and 4 root 2. Last one. What if my legs were 7? I bet you can guess. You have 7, 7. A squared plus b squared is equal to c squared. 98 is c squared, so c is the square root of 98. Does anybody know what I'm going to split the square root of 98 into? The square root of 49 times the square root of 2. Do you see the trend? In a 45, 45, 90 right triangle, 7 or 2. Here's the rule. Let me scroll up now. The two legs will always be the same. It's isosceles. To find the hypotenuse will always be whatever that leg is times the square root of 2. So here we go. First problem. In a 45, notice they don't give you out. They give you a 45 and a 90. I think that means this one's going to be 45 as well. In a 45, 45, 90. First off, Jagger, they don't ask for it, but if this is 6, then what's this going to be? 6. The two legs in a 45, 45, 90 will always be the same. And Matt, if these are 6, then what's x? 6 times what? Root what? Root 2. That's all you have to do, guys. If you have the legs, take that leg, multiply by the square root of 2, you have the hypotenuse. That's all you have to do. Now you just need to remember that shortcut. Need to remember how to get from leg to hypotenuse. A little bit more difficult. You're given that the two legs are 9 root 2. Let me blow it up a little bit. How do we get, and this for anybody, how do we get from leg to hypotenuse? What do we multiply by? If this was, in the last problem, this was 6, and this is 6, and this was 6 root what? So in order to get from here to from a leg to hypotenuse, we've got to multiply that by root 2 somehow. We've got to do 9 root 2 times root 2. How in the world do we do 9 root 2 times root 2? Let's go back and talk about how do you multiply roots. So you remember what the square root of, let's do the square root of 4 times the square root of 4. You can multiply square roots together. The square root of 4 times square root of 4, that's the square root of 16, which is 4. The square root of 5 times the square root of 5 is the square root of 25, which is 5. When you multiply a square root times itself, such as the square root of 2 times the square root of 2, what are you going to get? 2. So this is 9 times 2, or 18. The hypotenuse here would be 18. Okay. That's enough for the 45, 45, 90. Now let's do the 30, 60, 90. It's a different type triangle. You also have rules for a 30, 60, 90, and here they are. In a 30, 60, 90 right triangle, well, first off, let me remind you this, that the smallest angle, which in this case is 30 degrees, the smallest angle is always across from the smallest side. In 30, 60, 90s, everything revolves around that smallest side. Let's say it's 5. In a 30, 60, 90 right triangle, the hypotenuse will always be double the shorter side. That's your first rule that you need to know. Your hypotenuse is always double the shorter side. And if you want to, if you just know that rule, you got two sides of a right triangle now. Could you use the Pythagorean theorem to find the third side? Sure. If you did a squared plus b squared equals c squared, let me show you what you're going to get. 25 plus b squared is 100. Take the 25 over, gives you b squared is 75, which I believe can be split into 25 times 3. The square root of 25 times the square root of 3. That's your first picture of what a 30, 60, 90 is going to look like. Let's do one more and see if you see the pattern. In a 30, 60, 90, let's say this is 3. The hypotenuse is always double. And then if you don't remember the rest of the rule, you can always use Pythagorean theorem. A squared plus b squared equals c squared. Bring the 9 over. B squared is 27. The square root of 27 we can split into the square root of 9 times the square root of 3. So I get 3 root 3. Do you see the pattern now? To go from short side to hypotenuse, you multiply times 2. To go from short side to long side, you multiply times root 3. Let me scroll back up to the top. In all 30, 60, 90s, if you have a side length, if you have the short side length, to go from short side to hypotenuse, notice you have s and you have 2s, you double it. To go from short side to long side, you do whatever that s is, whatever that side was, times the square root of 3. First problem, it says find x and y. You're given a 30, 60, 90, and I know that because even though they don't give me 3 angles, if you have 90 and 60, I bet the other one's going to be 30. They have to add up to 180. So in a 30, 60, 90, now we're starting out with the more difficult ones here. Let me see. Let's start out, before we work that one, let's work this one. Then we'll go back to the more difficult one. In a 30, 60, 90, the hypotenuse will always be double the shorter side. So, Trace, take your calculator out there. My shortest side here is always going to be across from 30 degrees. In this case, my shortest side is 21. I need to know the hypotenuse. The hypotenuse is always double. So, Trace, what's the hypotenuse? If this is 21, then this is 42. Everybody good with that? To go from short side to hypotenuse, you double it. To go from short side to long side, where the medium, I guess you could say, it's the longer of the two sides, because you have two sides and a hypotenuse. If this is 21, how do I go from 21 to the y here? Alex, what do I multiply by? So that'd be 21 root 3. Now, if you wanted a decimal for that, the square root of 3, guys, that's like 1.6 something. You could actually type in the square root of 3 times 21 if you want a decimal for that. If you don't want to leave it, this is exact. What'd you get, Alex? Did you type that in?
It's like 1.722.
Is square root of 3, and then multiply that by 21.
36.7.
Try it again. One square root of 3 times 21. 36. Okay. 36 point what?
937.
Okay, so 36.4. So if you want a decimal for it, that's fine. But again, the reason we're showing you this is approximate. This is exact. So anytime you're building a bridge, you always want exact instead of approximate. So if you wanted the decimal version of it, that's how you'd find it. You can type in the square root of 3 multiplied by 21, you got it. Now let's go back to the hard one. Reminder, to go from short side to hypotenuse, you double it. To go from short side to the longer side, you multiply by root 3. But do you see the issue here? To go from here to here, you got to multiply by root 3. But I've got this, and I need to go back to there. Let's say, and here's your tip for this. If to go from point A to point B, for some reason, I multiply by 3. How do you go from point B back to point A? Take a number and test it. What if your number is 7? How do you go from point A to point B? You multiply by 3. What is point B? 21. Now, how would you go from point B back to point A? You would divide by 3. Same thing works here. If to go from 15, or excuse me, if to go from X to this, you multiply by square root of 3, we've got to divide by the square root of 3. I've got to do 15 divided by the square root of 3. Have we done that? I don't know. Here you go, watch. Divisions of these things, pretty easy. You've got rules, and you talk more about this in algebra than you do in geometry, but you just get a refresher course in geometry. To divide by a square root of 3, now this is going to sound weird, you actually multiply. Whatever square root you're trying to divide by, watch this. If I multiply top and bottom by root 3, look what happens. Multiply top and bottom. Whatever radical you're trying to divide by, multiply top and bottom by that radical. Carly, on bottom, what is the square root of 3 times square root of 3? Square root of 9, right? Which is 3. Remember when you multiply a root times itself, it gets rid of that root. And look what I have on top. You can't multiply those two. Please, don't even try. A number times a radical, you cannot do. So we leave it as 15 root 3. Can we clean that up some? The rule is a radical can be multiplied by any other radical. Legal. A number can be multiplied or divided by any other number. That's legal. But a number cannot be multiplied by a radical. A number cannot be divided by a radical. A radical cannot be divided by a number. You can't do root 3 divided by 3. That's not root 1. But a number can be divided by a number. What's 15 divided by 3? 5. So 5 root 3. Let's test that. Let me clean that up. So that makes this 5 root 3. And to check ourselves, how do I go from short side to long side now? Multiply by what? Root 3. So what is 5 root 3 times root 3? What happens when you do root 3 times root 3? You get 3. So 5 root 3 times root 3 would be 5 times 3, which is 15. It checks out. Now the last step here, how do we go from short side to hypotenuse? Multiply by what? 2. You double it. How in the world do you multiply 2 times 5 root 3? Here's the rule again. You can multiply numbers with numbers. You can multiply radicals with radicals. You cannot multiply a number with a radical. 5 times root 3, not legal. Okay, you leave it as 5 root 3. But I can't do 2 times 5. 10 root 3. Done. Next, and I think the last of these problems. Here you're given a hypotenuse. And we're asked to tell what the two sides are. Everything revolves around the shorter side. Dylan, once again explain to me, how do I go from shorter side to hypotenuse? Do you remember? The shorter side to hypotenuse. What's the relationship always between short side and hypotenuse?
I can't remember.
Do you know, Riley? Short side hypotenuse. It's half of it. Or the hypotenuse is double the shorter side. Is everybody good there? So if you've got a hypotenuse, then you've got the shorter side. That's pretty easy. To go from here to here, I multiply by 2. So to go from here back to here, I'll, like I said, divide by 2. What do you get? X is 5. If you have the shorter side, these problems are really easy now. Once again, to go from short side to hypotenuse, double it. And to go from short side to the longer side, you multiply by what? So that'd be 5 root 3. So once you have the short side, you've got all the other pieces, no problem. Trigonometric ratios. Sounds very difficult. But we're starting the foundations of trigonometry today. Trigonometry is the mathematics of the right triangle. The mathematics of triangles, excuse me, not necessarily the right triangles. The word trigonometry comes from 2 Greek terms. Just to give you some background on what trigonometry is. The word trigonometry comes from 2 Greek terms, trigon, meaning triangle, and metron, meaning measure. The study of trigonometry involves triangle measures. A trigonometric ratio, and we all know what ratios are, the same way ratio of boys to girls, same thing. A trigonometric ratio is a ratio of the lengths of 2 sides of a right triangle. Now here's where we're discussing right triangles. One trigonometric ratio of triangle ABC is AC to AB. This side length to this side length. So anytime we're talking about trig ratios, we're talking about the ratios of the side lengths of the triangles. And since, let's talk about this. Think about this. Since by angle-angle similarity, if you've got a right triangle, let's say that, well, let's do the 30. Since we've done 30, 60, 90s, let's say you've got 2 30, 60, 90 right triangles. And let's say that I've got this side length is 3. Nope, just kidding. The shorter side length is 3, and the shorter side length over here is 5. What are the hypotenuses? In a 30, 60, 90, if the short side is 3, the hypotenuse is 6. If the short side is 5, the hypotenuse is 10. Look at the ratios there. In a 30, 60, 90, the ratio of the opposite side, or the ratio of this shorter side to the hypotenuse, so that's a 3 to 6 ratio. In this 30, 60, 90, the ratio of the shorter side to the hypotenuse here is 5 to 10. Notice anything about those 2 ratios? They're both a half. So my question for you is, if I have a ratio of 1/2, if the ratio of the shorter side, I don't know what this is, but I've got this triangle, and the ratio of the shorter side to the hypotenuse is 5 to 10, 3 to 6, 4 to 8. Do I know that's a 30, 60, 90 right triangle? Yes. And that's the whole foundations of what we're going to do in trigonometry. Trigonometry does this for you. You've got 2 pieces of information about a triangle. And well, we start with right triangles. You have 2 pieces of information about a right triangle, whether it be 2 sides, whether it be an angle on one of the sides, or whether it be, well, 2 angles, that's not going to work. But you got 2 pieces of information, you know everything about that triangle then. It's kind of a hyped up version of the Pythagorean theorem. If you know a little bit about the triangle, then you know everything about the triangle. And that's where we're going with that. Here's the part that you really need to write down. SOHCAHTOA. SOHCAHTOA. Write that down, spell it out, make sure you know how to spell it. SOHCAHTOA. Here we go. Here's what that means. Some old hippie, called another hippie. Sine. The sine of an angle. And SIN, that's the abbreviation. It's actually sine, SINE. The sine of an angle is the ratio of the opposite side to the hypotenuse. The cosine of an angle is the ratio of the adjacent side to the hypotenuse. And we'll talk about what opposite, adjacent, and hypotenuse, what that means in just a second. The tangent of an angle, TOA, T-O-A. The tangent of an angle is the ratio of the opposite side to the adjacent side. Do y'all see SOHCAHTOA there? Sine, opposite, hypotenuse. S-O-H, cosine, adjacent, hypotenuse. C-A-H, tangent is opposite to adjacent, T-O-A. Again, looking at SOHCAHTOA, sine is the ratio, and you can just do it like this. Sine is the ratio of opposite to hypotenuse. Cosine is the ratio of adjacent to hypotenuse. And tangent is the ratio of opposite to adjacent. Now, what do I mean by opposite, adjacent, hypotenuse, and all this? Here's your triangle. In all right triangles, you have three sides. And we know one of those sides. We know that this is the hypotenuse every time. The hypotenuse is always located straight across from your right angle. Now let's call this angle A and angle B. And my question for you is, look at angle A. Which side is across from angle A? Is it this side? My first side or my second side here? Which one's across from angle A? The second side. So that side would be your adjacent or opposite? Opposite. If you're discussing, or if you're talking about angle A here, this is the opposite side. Do y'all know what the word adjacent means? Next to. Adjacent is next to. If you're sitting adjacent to somebody, you're sitting next to them. So if you're talking about angle A, this would be my opposite side because it's across from it. And adjacent would be right there next to it. Now, is it the only side that's adjacent to it? No, the hypotenuse is also adjacent to angle A. But what if I'm talking about angle B? First off, do I have the same hypotenuse? If I'm talking about angle B, has the hypotenuse changed spots in any way? No, it's right there. Hypotenuse is always crossing the right angle. What about opposite and adjacent? If I'm talking about angle B, is this still my opposite side? No. All of a sudden, this has turned into my opposite side, and this has turned into my adjacent side. So it all depends on what angle you're talking about as to which one's opposite and which one's adjacent. Okay, here we go. Now let's discuss on how to find these things now. Again, this is not pronounced sin. This is the sine of P. Anytime you're dealing with trig ratios, what they're going to do, first off, they're going to tell you, okay, sine, cosine, or tangent. Which one am I looking for? And then they're going to give you of what angle. And if I'm looking for the sine of P, first off, look into your notes. And remind me, Briley, sine. What is sine the ratio of?
Opposite to hypotenuse.
So opposite to hypotenuse. So all I'm looking for is I'm looking for the ratio of the opposite side to the hypotenuse in relationship to angle P. Everything's revolving around angle P here. And why do they have to give you an angle? Well, if they don't give you an angle, you don't know which side's opposite and which side's adjacent. So, Hunter, with that said, look at angle P. What side is opposite of angle P? So the sine of P is 15 over, Briley, what's the hypotenuse? Good. Easy as that. The sine of P is 15/17. Any questions? Another one? The cosine of P. Hunter, again, find angle P. And look in your notes, Hunter. Cosine is the ratio of what to what? Caught another hippo. Adjacent to hypotenuse. And what's the adjacent side? Who did I say? Hunter. If we find angle P, what side is adjacent to P?
8.
8. And what is your hypotenuse?
17.
So the cosine of P is 8 over 17. Any questions? Pretty easy, right? Tangent of P. Colton, find P. What's the ratio of tangent? Ratio of what to what?
Opposite.
So opposite to adjacent. ADJ. There we go. Find P. Colton, what's opposite of P?
15.
And what's adjacent to P? 8. So tangent of P is 15 to 8. That's the ratio. Can we handle that? We did those. Now we're flipping to the other side. Sine of Q. Here's Q. Sine, Jagger, look in your notes and remind me what sine the ratio of? Opposite over hypotenuse. Jagger, what's opposite of Q? Good. And what's the hypotenuse?
17.
8 to 17. Done. Another one? Cosine of Q. Matt, what's cosine the ratio of? From your notes, cosine is, called another hoopy, adjacent to hypotenuse. Matt, what's adjacent to Q? Okay, let's go through the three sides. You have opposite, you have adjacent, you have hypotenuse. Matt, which one's the hypotenuse? It's always the longest side, right? Or it's always the one across from the right angle. So this is H. Adjacent and opposite. Okay, this one's out of the story. Just throw that one out. Either this one and this one are either adjacent or hypotenuse. Or excuse me, adjacent or opposite. Opposite is the one that's the furthest from that angle. So Matt, which one's opposite? Here's your angle. Which one's farthest from it? 8. Does that make sense how to do it now? So that's opposite. That makes this adjacent. So Matt, cosine is adjacent over hypotenuse. Which one's adjacent? And hypotenuse is 15 over 17. Last one. Tangent of Q. Trace. Tangent's the ratio, I believe, of opposite over adjacent, right? Find Q. And remind me, Trace, which one's opposite?
8.
And which one's adjacent? Good. Everybody understand? Problem. This one, we're asked to find the sine of J. We're doing the same thing. We're just going to do it all in the same one. We're asked to find the sine of J, cosine J, tangent J, sine K, cosine K, tangent K. Let's start out with sine of J. And what we're going to do, you look in your notes. Well, I'm going to label J to begin with. There's J. There's that angle. You always find, by the way, you always find sine, cosine, and tangent of an angle. Not of a side. You find it of an angle. So sine of J, I'm not going to remind you. Look in your notes if you need to. Sine of J, Alex, what do you think? 5 and 13. Sine is ratio of opposite and hypotenuse. 5 is opposite, 13 is hypotenuse. The next one, Carly, find the cosine of J. Good. And finally, Dylan, the tangent of J. Perfect. Everybody understand that? Sine, cosine, tangent. Now let's go to sine, cosine, and tangent of K. First off, the sine of K. Do that one for me, Riley. Careful. Opposite. Use K. What's opposite of K? Farthest away from K? 12 over 13. Good. Do you see the relationship between the sine of J and the sine of K? You talk a lot about that later on in math. Riley, I want the cosine of K.
Sorry, 5 over 13.
Good. And finally, I want Hunter the tangent of K. Nope, careful. Opposite first. 12 over 5. Good. And again, notice the relationships. The tangent of each of the angles, what was that word I used for the flips? They are what of each other? They're not opposite reciprocals, but just reciprocals. Tangent of the two angles will always be reciprocals of each other. The sine and cosine of the two angles, notice that. The sine of J and the cosine of the other angle will always, because think about it. When you go from J to K, your opposite and your adjacents are flipping sides. So that's the reason that the sines and the cosines of the two angles will always be the same. Okay? Now you're going to put the two lessons together. And then we'll probably finish up with this. Use a special right triangle. And we can use this one or we can make one up. We're fixing to make one up. It might be a little bit easier. Use a special right triangle to express the tangent of 30. Notice they don't have A, B's, and C's here. They have just angles. To express the tangent of 30 as a fraction, let's try that. The tangent of 30. Because that's where we're leading up to. You don't find the sine of A. You don't find the sine. You find the sine of 30 degrees. You find the sine of 28 degrees. You find the cosine of 43 degrees. You find the sine, cosine, and tangent of angles. So let's try this. The tangent of 30 degrees, well, here's 30. That's this angle. And tangent is equal to opposite over adjacent. And if you would rather, instead of x, x root 3, and 2x, if you want to call this 6 root 3, and 12. Or if you want to call it 5 root 3, and 10, that's fine. But the tangent of 30, tangent is opposite over adjacent. What side is opposite at 30? The x, right? What side is adjacent to that 30? X root 3. Or in my case, if I want to use the 6 and 6 root 3. But look, it doesn't matter what I use. What happens to the 6 and 6? Don't they cancel? What happens to the x and x? What if I'd use 5 and 5 root 3? What if I'd use 4 and 4 root 3? The numbers always cancel, do they not? And leaves you with nothing on top and what on bottom? Root 3. And let me explain a rule. Don't leave radicals on bottom. Do not leave radicals on the bottom of fractions. What it's actually called is rationalizing. Always rationalize your denominator. This is an irrational number. And I think we talked about this issue. This is an irrational number. We don't want irrational for some reason in math. It's just one of those unwritten rules. For some reason in math, we don't leave irrational numbers on the bottom. How do I get rid of it? I multiply top and bottom by that irrational number. Because now what do I have? Do I have an irrational number on bottom now? What's the square root of 3 times the square root of 3? 3. Square root of 9, 3. So I just rationalize it. It was irrational. Now it's rational. Now it's a whole number. And on top you have root 3. So question, so no matter what numbers you use, whether it be 5 and 5 root 3, 4 and 4 root 3, 2 and 2 root 3, the numbers always cancel and leave you with 1 over root 3, which is always root 3 over 3. So the tangent of 30 will always be root 3 over 3. So what if I check, and I've got this right triangle. This is where it leads us to, guys. This is where we're headed. I've got this right triangle, and I've got this angle here, A. Well, actually, let's, for the sake of being drawn semi-scale, let's let that be my A. And I've got an opposite side of root 3, and I've got an adjacent side of 3. Do we know how big that angle is? 30 degrees. Because if the tangent is equal to root 3 over 3, we know the angle is 30, because the only time that tangent is equal to root 3 over 3 is if the angle is 30. So that's where we're headed with it. We can take, and if we know what the ratio is, then we can figure out what the angle is. Here's your word problem. It says a certain part of hiking trail slopes upward at about 5 degrees. After traveling a horizontal distance of 100 feet along this part of the path, what would be the change? And I don't think we're ready for that. I don't know how that snuck in there, because that's actually solving triangles. We'll get to that later. Let's use it now. And then once we use it, we're done for the day. And I'll give you some problems to actually try it yourself. SOHCAHTOA. Always start out, and here's the application problems. Always start out with some old hippie called another hippie. Okay. Always start with SOHCAHTOA. And look at the angle that they give you here. Here's how you're going to set up every one of these problems. This is the majority of your test, is what I'm going to show you. They give you this angle, and they give you this side, and they tell you to find this side. And we've got to find out. We know that sine is the ratio of opposite and hypotenuse. We know that cosine is the ratio of adjacent to hypotenuse. We know that tangent is the ratio of opposite to adjacent. We've got to find out for ourselves, what kind of problem is this? Is this a sine problem? Is it a cosine problem? Or is it a tangent problem? So that we can find out our missing pieces. Because we have one unknown. We have two things that they're giving us. We can find that missing piece. So given the 70 degrees, first off, is this, out of the three sides, hypotenuse, adjacent, or opposite, what is this? Does anybody know? That's the hypotenuse. And what is this? Because here's my angle. That's the angle they give me. So this would be the adjacent side. And we've got to use that information to determine what kind of problem is this. Does anybody know? It's a cosine problem. Because cosine is the ratio of adjacent over hypotenuse. And I have no idea why we're starting with one of the tougher problems, but we are. So here we go. We write an equation. The cosine of my angle. You find sine, cosine, and tangents of angles. The cosine of my angle is equal to. What's adjacent? Because the cosine is adjacent over hypotenuse, right? What's adjacent? 15. What's hypotenuse? Do you see you've got an equation? The cosine of my angle is equal to 15 over 8. Now, let me explain. From what I showed you on that past slide, the sine of 30 degrees, the cosine of 30 degrees, the tangent of 30 degrees is always a certain number. For those of you that's got scientific calculators, here's what I need you to do. I need to know what this is. I need to teach you how to type these things in. So let me pull my scientific calculator up and we'll here we go. On the TI calculators, here's how you'll do it. Cosine of 70 is a number. On all scientific calculators, you have 3 buttons. That's what makes them actually a scientific calculator. You have a sine button. Probably always wondered what it meant. You have a sine button, you have a cosine button, and you have a tangent button. I need to know what the cosine of 70 degrees is. Now here's one thing that, and I'll remind you before you take your test, and I'll remind you before you do your homework. For some reason, these calculators start out not in degree mode. You see degree right here? Well, I have to go down, and before I start my homework, I have to go over and change it to degree mode because I'm doing 70 degrees. You have no idea what a radian is right now. When you get to Algebra 2, we'll teach you about radians. But radians, it's a way to measure angles that it's odd to me, but it's not as common as degrees. So why do they start your calculator in radian mode instead of degree? But anyway, now all you got to do, I need to know what the cosine of 70 is. So you type cosine, you type 70, and you hit enter. The cosine of 70 is 0.34. What that means is, if you have a 70, 20, 90 right triangle, the ratio of 70 degrees, take that 70 degree angle, the ratio of adjacent to hypotenuse will always be 0.342020143, right? That'll always be the ratio. That's a ratio that's been changed to a decimal. So, let's go back to my equation. Cosine of 70, take it out. Put in was it 0.34? But leave it on your calculator because we're gonna clean this thing up. Now again, I started for some reason, I don't know why this first one on the sheet, started out with the hardest ones that there are. Because how do you solve that? How do you get x by itself? X is on bottom. We don't like it when x is on bottom. How do you get rid of it? Any ideas? What would you do? You have 2 options. Your first option, that's divided by x, right? Whoops. Try that again. There we go. Change my pen. That's divided by x. How can I move that x over here? Multiply by x. So that turns this into 0.34x equals 15. You can solve those, right? How do you get rid of 0.34? Divide by 0.34. So x equals... Now, I told you to leave that on your calculator screen because is 0.34 exact? Is the cosine of 70 equal to 0.34? No. Going back to my calculator screen, I've got to do 15 divided by this. On the TI calculators, you can type in 15 divided by. And I want to divide it by this answer up here. There is, right above the negative key, there's an answer, A and S. So I'm going to do 15 divided by the previous answer. Enter, I get 43.86. We'll call it 43.9. So x is equal to about 43.9. So what I just did was given an angle and one side, I was able to find a second side. Now, could I find the third side now? Because look, now it's a right triangle. I've got 2 side lengths, Pythagorean theorem. You've got the third side length. I've got one angle. How could I find the other angle? Subtract it from 180. So yeah, you can. Let's try another one of those. Oh, I didn't tell you the other way to work this. Go back to here. This is the easiest way to work it. If you have an x on bottom, can everybody in here solve proportions? You remember solving proportions? If proportions are like 3 over x equals 5 over 7, you remember solving proportions? How would you solve this? Multiply, good. Multiply 3 times 7, divide by 5. It's easy, right? Multiply the two numbers diagonal from each other and divide by the third number using the shortcut. Is this a proportion? No? Is it now? Sure. That's the easiest way. To solve this, you multiply the two numbers that are diagonal. You're going to get 15, and you're going to divide by what? 0.34. Same answer. Much easier. If you want to create a proportion, anytime the x is on bottom, create a proportion, solve a proportion, much faster, much quicker. Again, step number 1, we find out, is this a sine problem, is this a cosine problem, or is this a tangent problem? The way that we do that is, I'm going to write down Sakator. Great Indian man, invented math. Sakator. Here's my angle. What two sides am I given there? Here's the side I'm not given. Colton, what is this side? Is this the opposite adjacent or hypotenuse? That's hypotenuse. We're not given the hypotenuse, so obviously we're given the opposite and adjacent. Does that make sense? So what type of problem is it? Anybody? Opposite and adjacent. Tangent. Tangent deals with opposite side and adjacent side. This is a tangent problem. You write an equation. The tangent of my angle, I'm giving my angle here. Put it in there. Don't put ABC. Put the angle in there. The tangent of my angle is equal to opposite over adjacent. Jagger, finish the equation for me. Here's my angle. Which side is opposite that angle? And which side is adjacent? Good. Everybody understand that? And when you use that equation, you figure out what x is. The tangent of 25 is x over 18. Now, let's solve this thing. Last time I turned it to a decimal first. I'm going to show you now how to solve this thing because I want you to know this is a decimal. I'll show you. Let's go back to my calculator. Here's tan, right here. Tan 25, close parentheses, enter. That's 0.466. The tangent of an angle is a number. The sine of an angle is a number. This is a number. So how do I solve this equation? I've got a number equals x over 18. I've got to try to get x by itself. Matt, how do I get rid of that 18? Move it over by, this is divided by, right? Divided by 18, move it over by, here, what about this? 3 equals x over 18. Multiply by what? 3 times 18, right? To get rid of divided by 18, you multiply by 18. So you're doing the same thing here. Undo. You just multiply. So what I'm going to do is I'm going to take divided by 18, I'm going to move it over here and do times 18. So what is x? X equals 18 times tan 25. That way you can type the whole thing into your calculator. Does that make sense? So we go back to my calculator. Instead of just tan 25, if I want to do times 18, I could. But if you want to type the whole thing in your calculator, we're going to do 18 times the tangent of 25. Close parentheses. That gives me 8.4. So my missing side is about 8.4. Any questions? Have your homework.